Now, coming up soon, we'll review or we'll bring into our discussion things that we've seen before, but we might have forgotten exactly the definitions and the context of when we use them. So here on this page, we'll review a few things that are going to be important coming up soon. So the meaning of a p-value, also type 1 and type 2 errors, that probably vaguely sounds familiar, but maybe forget exactly what those mean. But first, the meaning of the p-value. So at this point, we assume you know how to use a p-value to make a decision in a hypothesis test. Given an alpha, they should give you an alpha, or it should be understood what alpha is. The logic is always the same. We pick a level of significance, alpha, then we compare the p-value to alpha. If the p-value is less than or equal to alpha, we reject the null hypothesis. The data supports the alternative hypothesis, but if, like in the last example we saw in the kiln-dried versus regular seeds or whatever, if the p-value is bigger than alpha, like it was, we'd fail to reject the null hypothesis because the data is not strong enough to support the alternative hypothesis. In fact, we find often that we often treat these as rules and apply them without thinking about why the rules make sense. When we understand what the p-value means, these rules are logical. So I'll pause here and review the meaning of the p-value, since it is the connection between probability and decision-making and inference, and one of the most important concepts of this whole course. Well, let's scroll down here and then we'll look at an example that talks about birth weight, which I'm sure we've seen before. Let's see, let's return to a familiar context of birth weights for babies in a town. Suppose that babies in the town had mean birth weights of 3,500 grams in 2010. This year, a random sample of 50 babies has a mean weight of about 3,400 grams with a standard deviation of about 500 grams. Here's a distribution of the birth weights in the sample. Obviously, the sample weighs less than, on average, than the population of babies in the town in 2010. A decrease in the town's mean birth weight could indicate a decline in overall health of the town. But does this sample give strong enough evidence that the town's mean birth weight is less than 3,500 grams this year? We now know that the answer to this question we'll answer it with the hypothesis test. We'll use a significance level of 5%, as is usual, unless otherwise specified. Let's let mu be the mean birth weight in the town this year. The null hypothesis says that there's no change from the old value of 2010. I'm assuming that the mean is the same. It's 3,500, but it seems like it's getting smaller. So my alternative hypothesis would be that mu, the mean birth weight, is now less than 3,500. Since the sample is large, n is, 50, which is greater than 30. That's our cutoff point for being able to use normal distributions and t-tests. We can conduct the t-test without worrying about the shape of the distribution of birth weights for normal individual babies. We calculate the t-score here. Let's see, I'm going to kind of zoom in so we can see it. The sample mean minus the previous mean, so x minus mu, over the sigma or sample statistic of standard deviation over the square root of n. Anyway, if you get the sample mean 3,400 for this current year minus the old mean 3,500 for the old year, divided by this sample standard deviation of 500 divided by the square root of 50, because that's the n value, we get negative 1.41. We'll use that now to calculate a p-value. Either an applet or a calculator, or sometimes there's a table of values. Statistical software tells us the p-value is 0.082 or 8.2%. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. So our conclusion is this sample does not suggest that the mean birth weight this year is less than 3,500 grams. Maybe the sample just happened to be a bunch of babies that are a little bit lighter than the average. It could be just due to random chance. It could be, honestly, that babies in this town are declining in birth weight, but we don't have strong enough evidence to say that for sure. The sample from this year has a mean of 3,400 grams, which is 100 grams lower than the mean in 2010, but this difference is not statistically significant. It can be explained by chance fluctuation we expect to see in random sampling. Statistical software tells us that a p-value is 0.082 or 8.2%. Since the p-value is greater than 0.05, we fail to reject the null hypothesis.